Welcome to our two speakers, Esther and Josep. We're looking very much forward to your lecture, Nature-Based Solutions for Resilient Water Management within the Acting for Water lecture series.
Thank you so much. Can you hear me? Everything is working?
Everything
Okay.
working fine?
Thanks. So we are Esther and Josep.
Hi.
Both of us work here at ICRA, and under the project multi-source. So today within this framework, we are gonna present some information about nature-based solutions for resilient water management. Before I will give some introduction on the topic, and I will present two case studies that we have with some results, and then Josep will introduce you the tool to help you decide which nature-based solution could you apply in your scenario, for example. Okay. Nature-based solutions. Well, I've been checking some definitions, and there is a wide range of definitions. So I try to pick the most simple one, let's say, to have everything together. So what I got was that nature-based solutions use natural processes as primary tools to address societal challenges, providing environmental, social, and economic benefits. Those challenges are related more in the environment, let's say, with water and food security, climate change, pollution management, biodiversity loss, and natural disasters. And more in the societal economic way, they are more related to public health, social equity and community resilience, socioeconomic development, and some urban challenges. As well, there are many ways of classifying the nature-based solutions, but I decided to choose this one from my ex-colleague, Joanna Castellar, and she divided in two types. So on the one hand, we have the interventions, which refer to the act of intervening ecosystems or other nature-based solutions to support natural processes. So these interventions act on the rivers, soils, and biodiversity. And we have some simple actions like, for example, planting trees in a proper way to avoid erosion or foster biodiversity through different natural processes. And then we have the units. The units are the topic that we are focusing in today's lectures. So these are standalone green technologies or spaces that support these processes. And for spatial units, we have, for example, the trees or the gardens, the parks that we have in our cities or towns, and also the technological units. We have a very long list, and I'm sure that there are much more. For example, green walls, constructed wetlands, ponds, and many others. Here I put you some examples in this picture. So in the first size, we have, as I told you, for example, planting trees, riverbank restoration, mangrove ecosystems to avoid erosion. And here you have a floatable park, which is a spatial unit, but it can also contain some technological units. So it could be a mix of them. So this type of solution help to cope with the rainwater in this case. So we avoid or reduce the risk of flooding, but when there is not that much rainwater, we can use it as a park. So going more into the topic of the seminar, which are nature-based solutions for resilient water management. I put you here some pictures as well. So you have some constructed wetlands with ponds to treat the wastewater. If we have some space constraints, we can use green roofs or green walls to treat rainwater, greywater, wastewater. And also here we have some rain gardens, for example. So we are focused mainly looking at urban or like domestic, let's say, scenarios. We are focused more on wastewater treatment and stormwater management. So applying these solutions for wastewater treatment will give us less polluted water prior to discharge or even with enough quality for reuse. And also stormwater management reduce the flood risk, and also we could reuse this water if we treat it. And it's very common, and one of the cases has these two types of water mixed together, for example, rain and waste or grey water. which we will also go back later on the gray water. So these solutions alleviate the climate change risks on the water resources mainly. They improve water quality. They have lower energy consumption than the classical, what we call gray technologies, and lower maintenance cost and more simple maintenance. But of course, since they are extensive systems, we have this problem or this issue with the large space that they require to treat the same amount of water that if we, for example, use membrane technologies, we will need higher space and longer operation time. So we have to cope with this. But also these solutions provide additional benefits. I am gonna present you the 7 pilots of the multi-source project. So then you can see a diversity of the scenarios, and there are many more where we can apply these solutions. But then here you can see the different types of solutions and also different types of water. So in the United States, we have in Montana a ski resort with a constructed wetland that remains frozen for some months a year, I guess. And this treats high-strength wastewater. Then in Norway, in Oslo, also a cold place, we have the rain garden that treats that storage manage the road runoff. We have a phytoparking located in Belgium that treats pre-treated wastewater. In Leipzig, in Germany, there is the green roof for rainwater management. Then within a pretty big, let's say, space park in Merano, in the north of Italy, there are the hybrid treatment wetlands that work with combined sewage overflow. In France, next to Lyon, there are the pilots of constructed wetlands that treat raw domestic wastewater from a nearby neighborhood. And finally, here at ICRA, that I will show you a little bit more, we have the green wall to treat gray water. So how these solutions work? So in general, we have an inlet of any type of wastewater, rainwater that usually contains a wide array of contaminants depending on the source, but we have salts, pathogens, organic emerging contaminants, viruses, bacteria, a lot of contamination sometimes. So in general, this water goes to the solution, no? Most commonly, the solutions have a substrate, and very, very commonly, there are plants in the nature-based solutions. So the contaminants, the water with the contaminants enter in the system, and if the water is exposed to sunlight, the contaminants experience photodegradation. Then they can also experience sedimentation, absorption, and precipitation within the substrate. Also within the substrate, we have microbial degradation. And as well, we have microbial degradation thanks to those microorganisms that are attached to the roots of the plants. Also, the contaminants can enter the plants through the root, which is called root uptake, and they can translocate. So they can go from the root to the shoot, to the leaves, to other parts of the plants. We have detected contaminants in the leaves of the plants, for example. And finally, within the plant, they can also be metabolized and further degraded. So the outlet that comes from these solutions has usually low level of contaminations because the removal rates are pretty big, but usually the quality is not good enough for reuse. It is for discharge, but not for reuse. So most commonly, disinfection step is required in order to load the bacterial load, and then we can safely reuse this water. In scenarios like here in Catalonia, where we have droughts, it's very important to take this into account. So we could use it, the most commonly used are for irrigation or toilet flushing. Apart from that, we have co-benefits from these nature-based solutions that we don't have from other types of technologies. So more for the environmental side, they regulate the temperature, they reduce the risk of disasters, they improve the air and the water quality, they enhance the soil health and biodiversity fostering. And looking more at the socioeconomic co-benefits, we have improvements in health and well-being of all creatures, not only humans that are around, community resilience and engagement, recreational and educational values, and yeah, social equity and cultural value, and finally they can increase the property values. So if we have green spaces, we are all happy surrounded by green spaces. So this increase the quality and the value of the place that we have these solutions. So now I will show you 3 cases in which nature-based solutions are applied, and we have them around here. So we are here in Girona. And then in the north of Girona, very close to France, in a little village, there is La Viñeta Winery. This is a very nice space where they combine the production of wine. They have the vineyards here, they have the shop here, and the cellar. Henry, you are mute you, please. And there is a cheese factory as well, and they have like 2 rooms for guests, and also a meeting room. So they have a combination of different types of water and activities as well. Then here in ICA, in our research institute, we have super recently installed a green wall for greywater treatment. And finally, next to Barcelona, there is Sant Quirze del Vallès, a village in which there is this social housing, where there is another solutions that I will show you now. So starting by the most complex water, this is the treatment train. So yeah, we gather water from the cheese factory, the winery, and the toilets. It's all the wastewater, and this is particularly complex sometimes because, yeah, when there is the harvesting or the wine making process or the cleaning processes, the water varies a lot, the quality and also the quantity. So it's a little bit challenging, but we have good results. Then after a pre-treatment with a filter, the water goes through an anaerobic digester, hydrolytic anaerobic digester. So there is a diversity of bacteria, and they transform, let's say, they break the complex contaminants into more simple, so they can be assimilated by the nature-based solutions. Here we have two outlets, let's say. So the water passes through a horizontal subsurface flow constructed wetland. This means that the water is below like we cannot see the water, it's like below, so then we avoid the mosquitoes, smells, and everything. And then the flow is horizontal, so it means that the wetland is constantly flooded. So we have mainly anaerobic conditions. And then with the solid part that settles in the reactor, from time to time, we send it to the vertical flow. So it goes into pulses, no? And it's also treated. In this case, it's mainly aerobic, and then we have some anaerobic conditions in the down part. And we are evaluating the possibilities of reusing this water to water this treated water to water some olive trees or other trees that they have there in La Viñeta. And also we would like to study, to evaluate if the treated sludge can be applied as well as fertilizer. Here you see some pictures of the system. So this is in May of last year. Here you see the water because we just planted. So for 2 weeks, the wetland has like higher water level for the plants to adapt. And also you see that there is water, you believe me. And then in August, when we came back some months later, you can see that the system was very nice. The plants grew. And actually here you see in the picture that the water coming from the wetland is, well, less turbid. Like you see here, just with a simple picture, the action of the nature-based solution. Some results, we don't have that many, but I wanted to show you a little bit. So from the past spring, summer, the inlets and the outlets of the constructed wetland. So you see a very high reduction in COD, also nitrate, some reduction, and phosphate, we don't have that big reduction, but I wouldn't say this is bad, because if we want to apply this water for irrigation, if we have phosphate, it's good, no, because it's a fertilizer also with the nitrate, so it wouldn't be a big problem. Then I have the removal, the system removal, also for June 2024. And as you see, the whole system removal, or even the different components, are pretty high, especially in COD, BOD, and solids. So it works pretty well. The problem is that the effluent doesn't comply with the European reuse legislation. So it complied with solids for all reuse scenarios, and with E. coli, we could use this water with this concentration of E. coli only to water like seed crops and industrial crops. So I don't think they could use that for watering the olive trees. And also the BOD is over the limit, like it's the double of the limit. So definitely we have to, to improve the performance of the system. But look, like the removals are very high. The problem is that the water has a lot of contamination, but by including another step, I'm pretty sure that we will reach the reuse quality. Then before going to the other examples, I'm gonna just indicate you some data on gray water. So gray water is the fraction of domestic wastewater excluding the toilets, which represents between 50 to 80% of the total domestic wastewater, which is translated into 100 to 140 liters per person per day in Europe. So imagine if we can treat and reuse this water, which is particularly important in some regions as this that we are in the Mediterranean. And also this water is considered low strength wastewater because it's less polluted than the total fraction of wastewater, and it contains less solids, but of course it contains other contamination, salts, and emerging contaminants, so we have to treat this water prior to reuse. Among the different types of gray water, what is called the light gray water is the highest interest, let's say. So if we cannot treat the whole gray water in our home or wherever we want to install these solutions, we can only think about light gray water, because it's that one coming from the showers and the toilet sinks, which is way less polluted, is super diluted, and it represents 60% of the gray water fraction. So imagine at least 50 liters, like 60 liters per person per day that we could treat and reuse. And also, this has a high on-site reuse potential, and thinking not only on houses or like more domestic buildings, residential buildings, there are other scenarios that I was thinking that they produce even more gray water than like the typical, so they have higher potential. So I was thinking in, for example, schools and university, office buildings, hotels and camping sites, or sports centers where they have like a lot of showers, a lot of rooms, and they produce a lot of rainwater. So this could be very interesting to explore. So this is the treatment train of the ICRA green wall. So we harvest the water from the kitchen sink and from some toilet sink that we have here in the building. So it goes through a filter and a grease separator, and then it goes to the green wall. And finally, we will evaluate the possibilities of reusing this water for irrigation of hopefully some edibles that maybe if I do a seminar in 1 year, maybe we can have a salad with those. So I don't have any result about this because literally I will start working with this wall next week, but we are very happy because it's built, it's here, you see the picture. So it's this wall combines the vertical and the horizontal treatment. So in the vertical flow module, so the gray water comes through the top part of the wall, we have more aerobic condition because the water comes and and flows, and then it doesn't store there. And then the water goes to the horizontal flow treatment In this case, we have more anaerobic conditions. So with this, we have nitrification and denitrification, and also depending on the contaminant, they need one conditions or the other. So it's a very good idea to have these two types of treatment options. So yeah, in the future, in the near future, I hope this wall will be full of plants that we have to include. We will try different substrate, and we will be working on this. So this is a real case that we've been monitoring for over a year. The one in San Quirze del Valles. In this case, we also, the greywater is gathered, but only from the toilets. And in this case, it combines also the rainwater harvesting. So from the rooftop, they have like some pipes, and they can send the rainwater when we have rain also in the tank. So this mixed water goes through a pretreatment, also a filter, and then it goes to another green wall. And after a disinfection step with ozone, it can be reused, and it's actually reused for toilet flushing. So this is a real application. It's been like that for like over a year. And then here you can see the wall. So the wall is in a little high. So people cannot access, there's no safety concerns with some water or whatever. And then here for you to see how the wall looks like with like plants that they were planted like kind of recently, let's say, and when the plants are have grown a lot. Very simple, the treatment, how it goes. So the water enters through the upper part, and it goes through horizontal flow through the different compartments of the green wall. And then it goes out, passes through the ozone, and then we can reuse it for toilet flushing. These are the results of around 1 year of monitoring, the average results. So, and check it that both scales are logarithmic. So we have the inlet with some around 100 of BOD, some solids, nitrogen, and just a little bit of phosphate. But then you see how the outlet is like very, very low concentration. So the system works pretty nice. Also, E. coli is only detected at the inlet, and a little bit of coliforms at the outlet, but it's not that much. So this water is indeed safe for toilet flushing, and the neighbors are using it for some time. And just to show you here how high the removals are in most of the cases, not in the phosphate, but we saw that the phosphate concentration is very small, so it's not a problem. And also I wanted to show you a little bit of the organic contaminants that we monitor. We monitor, I don't know, 70 something organic contaminants, but we only detected, well, classical, of course, caffeine, we would detect, and DEET is a pesticide, let's say, so it can be found also in the creams for the mosquitoes and these things. And also benzotriazole is a plasticizer, so maybe it comes from the pipes or something like that. The concentrations are pretty small, and the removals are very big, so it's safe to use this water. So within this, you can see like some scenarios of the application of these solutions and how they can work, or in the other case that they need to be optimized, but they are working pretty well. So just to finish my presentations, we saw that nature-based solutions have the potential to restore ecosystems and enhance urban environments. They offer promising and practical approaches to address water management challenges as floods and droughts across diverse scenarios and water types. They are super versatile, these systems. And finally, we think that the adoption of these solutions should be promoted because they enhance water resilience in many scenarios. They generate, together with other technologies, effluents of reuse quality that are very important in specific places, and they also offer multiple co-benefits. So yeah, these are very, very nice options for resilient water management. And with that, I want to thank you for attending, and I will leave the floor for my colleague, Josep.
Hello, everybody. I'm Josep Pueyo, also researcher at the Catalan Institute for Water Research as Esther. And now I'm gonna introduce you one tool for and not for what, which is an online tool to select, compare, and explore nature-based solutions for water management, which is a tool that we developed within the multi-source project. So the challenge here is, as you saw in the Esther's presentation, there are a lot of MBS that apparently do the same thing, treating water. Actually, they are not the same. So they have different removal performance, but they also provide different co-benefits. They have different issues regarding space requirements or operational constraints. So how do we choose among all these options that MBS offer to us? No. So this is where we think that a decision support tool can fit and can satisfy these needs, this challenge. So our proposal is not for what, which is a web-based tool, and that is already available at this address, or also using the QR code, notforwhat.icradep.cat. And what is Net for What in a nutshell? Net for What is a catalog of nature-based solutions for wastewater treatment and for stormwater management, for both. Net for What also has several algorithms to select fit-for-purpose nature-based solutions based on the scenario defined by the user. Also models to estimate the surface of the solution, not very accurate and very sophisticated models, but we here opted to use simple models that are fast and are quite accurate, but you cannot trust these models just to, after using the tool, start digging to build your MBS, because the idea of Net for What is that the last step is that you contact a company to help you to build your MBS, not doing like auto construction, no? Because this is a very complex issue and we need experts for that. Net for What also provides a catalog of technology providers. I just explained why, and a catalog of scientific publications. Okay, this is the main workflow that the users go through when using the tool. In the first step, they define the water scenario, and this means the type of water. Actually, the type of water is the only mandatory input, and we will see other inputs. Then the tool gives or provides a list of all the suitable nature-based solutions that could handle the scenario defined. Then the user can choose all of these suitable MBS or only a subset of them to compare using a multi-criteria decision analysis when we consider co-benefits, but also space requirements and operational constraints, like the complexity of operating the technology or if they use energy, these kind of things. And finally, based on the information provided by the multi-criteria decision analysis, the user decides, and this is important, is the user who decides, not the tool. The user decides which is the best solution for their case. Once the best solution is selected by the user, the tool provides market cases and scientific publications related to this tool to explore the knowledge that is available for this selection. So how the Net for What is being developed. Actually, the tool was initiated in another project, a project called SunNat, funded by the Nature Conservancy. And in this project, they developed the prototype and also the expert workshops that provided all the knowledge base that is feeding the tool under the hood. In the multi-source project, we continued with this experts workshop, validating the tool, providing new solutions, validating also the information provided by the former experts. We also do a review of scientific evidence to validate the expert opinions, but also to provide data about treatment performance, for instance. And finally, we are integrating also in the tool the experimental data from the 7 pilots of the multi-source. In the first step, as I said, the users define the scenario. And here, the important message is that the complexity is flexible. As I said, only type of water is mandatory, but users can provide additional information as long as they have it. For instance, here we can see information for a stormwater management scenario, like the accumulated rain, the catchment area, the type of soil that the MBS is built on. For water treatment, we can provide concentrations in the inflow, target concentrations we need in the outflow, and also co-benefits that we are interested in or operational constraints that we want to avoid. With all this information, the tool returns the available solutions that, as I said, can be selected, all of them or just a subset, to go to the multi-criteria decision analysis. But before that, to guide this decision, the user can open, you can see here this icon of information. So if you click here on a solution, this card is open about all the information of the solution. And you can see here for wastewater treatment, in this case, an aerated treatment well, you can see the pollutants that the solution is able to remove, the co-benefits provided, the operational constraints, and the surface estimated using the models that we have, and also an approximation of the construction cost that this varies among countries. So we provide a very rough estimation about being 1 order of magnitude accurate. And also for stormwater management solutions, instead of the pollutants, we have information about if the solution is able to infiltrate into the ground or is a sealed solution, the storage capacity, so this is the porosity of the retention layer, and the hydraulic conductivity, so how fast is the water entering in the solution, and the same information as before. If you click in the case studies button on the bottom, you go directly to explore market cases and scientific publications for this solution. So here we can see the knowledge base that is used to fit the algorithm that select the best solutions or the suitable solutions. This is mainly just a table with yes or no's. For instance, here we can see in the case of the treatment level target, the pollutants that the solution can remove. If the user selects that the solution should remove nitrates, all the solutions that are I stands for inactive, all the solutions that are inactive for nitrates are rejected from the list of suitable solutions. And this works the same for all the criteria that the user can define in the scenario, also for co-benefits and for operational constraints. Here we can see the model that we use to estimate the surface for stormwater management solutions. This is a simplified volume mass equation that as the parameters use the volume that the solution is receiving, that is the rainfall multiplied by the catchment area. And the parameters are the area, which is the surface of the solution, the porosity, the depth of the solution, and also the hydraulic conductivity of the solution, and also the hydraulic conductivity of the receiving soil. And also the equation includes the possibility of installing a drainage pipe for a faster drainage of the solution. If we can use this equation just to isolate the surface area required, and then from here we can determine the surface. And this is the model we use to determine the surface for wastewater treatment solutions. In this case, we use a cascade of models that depend on the information provided by the user and also in the information available in our database. The first step is the data-driven models. In this case, these are regression models. We compare a linear, an exponential, and a power model, and we use the most accurate. However, if these models are not accurate enough, or we don't have more than 5 observations for that combination of solution and pollutant, we don't use these models. So then we try to estimate the surface with the state-of-the-art models. These are mechanistic models that are based on physical parameters. But if we don't have a model available for a specific solution and pollutant, then we go to the next step, which are using the organic loading rate, which is the quantity of organic matter that a solution can handle per square meter. However, if we don't have this information, or the user is only providing the people served by the solution, so we don't have the BOD concentration, then we are using what is called the rule of thumb, which is a measure of the square meters per person equivalent that the solution needs. This is the last step. We have data for all the solutions, so we can always estimate the surface using the rule of thumb, provided that the user is providing at least the people that is served by the solution. If the user is only providing the type of water, for instance, we cannot calculate any surface because we don't have not the people served, not the inflow, not the concentrations. So we estimate this surface for all the combinations of solutions and pollutants. So we can estimate the surface for BOD, but also for COD, for total nitrogen and for ammonia, which are the usual pollutants used to design solutions. And from all these combinations, we return the minimal surface to fulfill all the removals needs. So that is, if a solution needs more surface to remove the total nitrogen needs of the user than for the organic matter, we return the surface that is needed to remove the total nitrogen. I don't know if I'm being clear on this, but okay, this is the idea. Okay, once we go to the third step, we selected the solutions that we think can fit our needs. Then we compare these solutions. In this case, we can see a comparison of 3 stormwater management solutions, which are detention basin, extensive green roof, and a bioretention tree pit. And we compare these technologies based on environmental impacts, biodiversity, space requirements, so the surface that is needed, social benefits like recreational functions, aesthetical values, and also flood mitigation, for instance, and temperature regulation. Circularity, like if they are good for water reuse, or if they are producing food, for instance, or another type of biosolids. The construction costs and operation and maintenance requirements. And also for wastewater treatment solutions, we also compare using a criteria which is treatment performance, which is maybe the user is only interested in BOD, but we also compare the solutions if they are able to remove nitrates or ammonia or pathogens or any other pollutants. And also the users can weight this criteria in a scale from 0 to 5, from this criteria is not important to me to this criteria is extremely important to me or very high. And then they get one score for each solution. As I said, then they can select the one with the highest score or another solution that fits better for their scenario. Once the solution is selected, the tool provides advice on this best solution, no? And the users can explore scientific publications that are focused on that solution, and also market cases provided by companies. In this case, we see here the irrigated treatment wetland, which has 6 market cases, and here on the bottom there is one market case provided by Ridland, and the users can also see the information about the company that has built this market case or designed it, and they can see the website, the email, and also the portfolio of these companies, which is all the market cases that this company has provided to the tool. So they can contact them for further information and detailed design. Also, the tool provides a graphical interface, which we dedicated a lot of effort to make it user-friendly and easy to access and available to everybody. But also for programmatic access, mainly for scientific purposes, the tool also has an API for programmatic access that you can, in case you want to access here in this link, there are the documentation to access the API. The API is free to use. You don't need a registration, not a token. And it's, for scientific purpose mainly. So thank you. And maybe I can show you now a bit the tool. Okay, here you can see the tool. Here you can see that you need to register to access the tool, but only for the option of find your solution, because here is where you create the scenarios. So if I click here at your scenario, you can set the scenarios based on what I explained. And these scenarios are stored in your account. So you can create several scenarios and explore them. You can also duplicate them. So this is why we ask for a registration account. But there are also other options like the list of solutions that are available in the tool, also the scientific publications and the market cases that are available without registration. For instance, here we have the market cases with the companies that provided them, and we can explore, for instance, one of them. If you enter here in the market case, you can see a picture, a description, with information about the construction cost, the operational cost, if the company provides them, the surface, the people served, etc. And here you can go to the company information, which is the one I show you, and you can go to the website, or you can check the portfolio, for instance, of this company. And here we can see the 17 cases that this company leader has provided to the tool. Yeah, this is a very brief demonstration of the tool. Because we don't have more time, I think we should go to the answers and questions, to the questions and answers. So feel free, please, to use this tool. And in case you want to provide feedback, here in the test session, there are 3 links to report the accuracy of the tool if you are experts in nature-based solutions, also the user experience, and to suggest improvements if you think something can be improved. So please feel free to contribute also. So I don't know if there are questions in the chat.
So far, no questions in the chat, but maybe some of the participants still have open questions or would like to see more. Okay.
Hi, thank you for the wonderful presentation. It was really inspiring. I thought I'm a master's student of water technology in the Netherlands. So I found that just really inspiring, thinking about things I could do in my own city that are nature-based solutions. But I did have a question about the co-benefits of the MBS for the plants. So one of them said that there was improvement of soil health as one of the co-benefits, but I don't understand how that would be a benefit, since probably, to me at least, the soil would be saturated with pollutants that are no longer in the water. So is the soil then there's something added to the soil? Is there a later removal of the soil pollutants? I was just wondering about that.
Yeah, for example, something that I can think is not that the soil is the nature-based solution, but if you install a nature-based solution close to a, I don't know, for example, to retain the rainwater, then, or to avoid erosion, that's why this is a co-benefit. Would you say it would be a direct action, but the co-benefit is something extra that we get? So that would be the thing to go. Yeah. So if you, for example, this very simple planting trees to avoid erosion, you are increasing soil quality because you are not having that, for example.
Thank you.
Welcome.
I think there is another question.
Shall I go? Yes, I think so.
Yes, please do.
Yeah, okay, yeah, Sebastian. Yeah, first of all, thank you very much for the presentation, both of you. I have a question for Esther. Esther, I saw it in slide number 14. It's a pity that the slides went away, but on slide number 14, you were discussing that you found or you removed benzotriazole, but you really ruled it out as it was a plastifier or plasticizer on the tubes. Could you elaborate a little bit more there? Because I'm a little bit more curious about the benzotriazole.
Yeah, this is only my guess that I thought while I was doing the presentation. I worked with benzotriazole for some years ago, actually, and it's basically present everywhere, mainly. So it's like a plasticizer or an industrial chemical, something that is used like for coating, I think. I mean, it's a component of that, if I'm not wrong. So yeah, I was thinking that maybe it comes from the pipes, but it can come from already the tap water that might have very low concentrations. I mean, the concentrations are very low, so there are some emerging contaminants that they are not arriving in the wastewater because the user is producing, but because they were not properly removing in the drinking water treatment plant, so they arrive in our tap. So I think it's a combination of both, it could be. But benzotriazole is everywhere, basically, or in many places, at least in Europe. Yeah, but the concentrations are very, very small.
Yeah.
I don't know if I answer.
No, I think I will.
I cannot know the origin. It was only like a guess. I mean, the caffeine, yeah, the origin it's more clear, for example, but the benzotriazole, it's yeah.
Because that was gray water, eh? In the house, or it was what it was? Which kind of water it was? It was gray water, eh? If I'm not
Gray
mistaken.
water. Yeah, from the showers and the sinks.
And in your solution, you also have some kind of a SAM filter embedded. I mean, you also have the soil with the plants and everything. Oh, it's
there's
how
no
it was
soil.
that one.
Yeah. No, there is the filter is like a physical one, just to for some fibers or something that can be the gray water, and then it goes directly to the green wall. But there's no soil like that. It's not that heavy.
Okay.
It's a combination of different substrates. So we have these light expanded clay aggregates combined with other types of substrates. So with different size, porosity, and this is when we get the absorption of the compounds and the degradation, and then for disinfection we have the ozone, but we don't have some filter.
But you also have some kind of bacteria also growing there and also doing some activity, isn't it?
Yeah, of course. I guess in the wall, yeah. It
Okay.
would be very nice if we could sample and make a PCR of what is the community that we have there. But
yeah, that's it. I think it's very interesting. No, I think because we also have a similar project in another kind of a technology, and we observed that some bacteria is creating benzotriazole. So we have a regrowing on the system, and since you rule it so fast, so out, I was like, I think that we are facing the same issue. So I will, if you don't mind, I will contact you later, and maybe we can see what is going on there, because we are just really interested on this phenomena.
Oh yeah, sure. I didn't know about this, to be honest.
Okay.
So, very interesting. Wow.
Thank you very much for that.
Thank you.
Thanks for the presentation, both of you.
Thank you.
Hi. Hello, I also had a question. All right. Sorry. In the emerging pollutant removal, what is the effect of the ozone? The removal was only for the green wall or for the nature-based solution, or also for the ozone?
You show both, I think.
I'm not. No.
So you don't have like the which percentage could be because of the ozone, and which would be because of the nature-based solution?
I'm looking for because now I don't remember. I mean, for sure we have this data. No, I use total contaminant removal. We have this data, but I didn't. I present the total removal, so I can check it. Yeah. I don't know. I think it's more in the green wall than in the other, but I have to check. I mean, we are preparing a paper on this, so if you want, when we have it, I can also forward to you. That's why I didn't include that much data today, because we are elaborating the paper. So if you want, Teresa, I can.
Okay, thank you.
Are there any other questions still? Seems everything clear and fine. Otherwise, you also saw the contact details, so I'm sure they'll be happy to answer any questions later on still.
Yeah, that's very cool.
But then let's thank our speakers again for this very interesting and engaging presentation. And I wish everyone a very nice and pleasant weekend, hopefully with better weather than is foreseen for us here. And see you hopefully in our next lecture next week on Wednesday.
Thanks a lot.
Thank you all. Goodbye.
Bye.
Nice to meet you.
Bye. Thank you.